Hey Becca, what are we learning today?
Today, we're finding the vertex of a parabola. The general form for the equation of a parabola is y equals ax squared plus bx plus c. When our a value is positive, our parabola is upward facing. The trick I like to remember is that if it's a positive a, then our parabola is smiling. The lowest point on our upward facing parabola is known as the vertex. Since the parabola is upward facing and the vertex is the lowest point, then the vertex is the minimum of the function. In a parabola where our a value, we have a negative parabola is downward facing, and since our a is negative, our parabola is frowning. This point up here is also known as the vertex, but in this scenario, when our parabola is downward, the vertex is the maximum of the function because it's the highest value on this function. Now, if we want to calculate what the vertex point is, what this coordinate actually is, we can use a simple formula to find the x-coordinate of the vertex, and that formula is negative b over 2a. This will give us the x-coordinate of our vertex, and in order to find the y-coordinate of the vertex, you just have to plug this value in for x, and you'll be given the y value. So your vertex is going to be a coordinate x comma y on the function. Here's an example of a parabola, and we want to find the vertex. In this case, our a is 1, b is 2, and c is negative 5. We're going to use these values in order to find the x-coordinate of the vertex, negative b over 2a, which here is negative 2 over 2 times 1, negative 2 over 2, which reduces to negative 1. So negative 1 is the x-coordinate of the vertex, which I'll put up here, and we still need to find the y-coordinate, and we can do that by plugging negative 1 in for x in this equation. Y equals negative 1 squared plus 2 times negative 1 minus 5, which equals 1 positive 1 minus 2 minus 5, which equals negative 6. So negative 6 is our y-coordinate for the vertex. So if we want to sketch our parabola, we can find the vertex, negative 1, negative 6, let's say that's somewhere down here. And our a is a positive 1. So since our a is positive, this parabola opens upward. And you can sketch it like this with the vertex at negative 1, negative 6. Here's another example of a parabola, ax squared plus bx plus c, but notice that we don't have a bx term here, so our b is just 0. If we want to find the vertex of this parabola, we use negative b over 2a, which equals negative 0 over 2 times negative 3. But since we have a 0 in the numerator, this will equal 0. So 0 is the x-coordinate of our vertex, and if we want to find the y-coordinate, we just plug 0 into our equation. y equals negative 3 times 0 squared plus 4. And since this term is 0, it goes away, and our y equals 4. So 4 is the y-coordinate of our vertex. If we want to sketch this, 0, 4 is right here on the y-axis, but notice that we have a negative a. So since a is negative, our parabola is frowning or downward facing. So if we sketch it, our vertex here is the highest point on this graph, so our vertex is the maximum. In this last example, I'm going to show you a real-world application of the vertex of a parabola. Say you have a pen in your backyard that's in the shape of a rectangle. If these sides are of length x and these sides are of length y, and say you only have 400 feet of fencing to go around the pen. 400 feet would therefore be the perimeter of this rectangle. So 400 would equal 2 x's, because we have 2 x's, plus 2 y's, since we have 2 y's. And if you wanted to build this pen so that you maximized the area inside, then we need to maximize the area of the rectangle as a function of x. The area of a rectangle is just length times width, or x times y. But this area function must be a function of only x, and we have a y here. So we need to find y in terms of x to replace in the area function. And we can do that using the perimeter equation. 400 equals 2x plus 2y. And we want to isolate the y to put it in terms of x. How do we get y by itself? First, we can subtract 2x from both sides, and we get 400 minus 2x equals 2y. And then we can divide both sides by 2. You can divide both of these terms by 2, and we get y equals 400 over 2, which is 200, minus 2x over 2, which is just x. So y equals 200 minus x, and we can plug this in to the area function. So a of x equals x times 200 minus x. And if we distribute, area of x equals 200x minus x squared. I rewrote the equations that we need in order to solve this problem of maximizing the area within this pen that has a 400-foot perimeter. This was the area equation that we came up with when we found y in terms of x, and we plugged it back in. Area of x equals 200x minus x squared. And I'm just going to rewrite this by plugging the x squared in first, so that our parabola is ax squared plus bx plus c form. So our area function is in fact a parabola because we have an x squared term as the highest degree, and we want to maximize the area. Notice that our parabola has a negative a value. A negative a value means that the parabola faces down and the vertex is the maximum value in the function. So by maximizing the area, all we really need to do is find the vertex, which will give us the x value that maximizes this area. How do we find that x value? We use our equation, negative b over 2a. Our b term is 200. Negative 200 divided by 2 times negative 1. Negative 200 over negative 2, which equals 100. 100 gives us the x-coordinate of the vertex, or the x value in our rectangular pen. Now, how do we find the maximal area? We plug 100 in for x into this equation. Area equals negative 100 squared plus 200 times 100. And we get 10,000, negative 10,000, plus 20,000, which equals 10,000. And the units is feet squared. That is the maximal area of our pen. And we know that this is x in our rectangle, so the only thing left to find is y, and we know that y equals 200 minus x, so y equals 200 minus 100, which equals 100. So now the dimensions that create the maximal area are 100 by 100, and the area is 10,000 feet squared.
Thanks for watching my video today on finding the vertex of a parabola. If you found this helpful, give it a thumbs up and make sure you share it with all of your friends. We're posting new videos every Monday and Thursday, so subscribe to stay up to date and follow us on Twitter @TheFearFactor. Have a great day!